then would shuffle that list, take the top two, have them fight. The winner would go on to the next round, which was represented in later on in the list, and the other one would be destroyed, which theoretically means that the list only ever has to store 1.048576 million AI. However, Python, when deleting things, just sort of keeps them around in a bin. It's pretty shit like that. And so, 6 hours, 40 minutes later, the thing crashes. Can't actually process that many AI. Theoretically, I could run 4 or 8 or 16 different tournaments and then consolidate the winners of those, but I don't know how far through the first round it even got, because my logs weren't that specific. It could have got through half of them, it could have got through a quarter. I don't know how much I needed to divide up these tournaments in order to find an actual winner. So, at this point, I only had a couple of days left, and I realised I needed a new type of AI to more organically learn how to do this thing. So, I thought to myself, the cards in Love Letter each have a value assigned. 1 is the guard, 2 is the priest, 3 is the baron. And mathematically, it's very easy to plug numbers into functions. Like, the easiest function is x squared. 1 squared is 1, 2 squared is 4, blah blah blah. But the problem is, there is no real mathematical correlation between the numbers on the cards and their function, their purpose, if it's good to play them. And so I couldn't have a function like the first number squared minus the second number. If it's positive, play the first one, whatever. Something easy like that, that just wouldn't fly. So I realized I had to make a function that would take in 2 variables, x1, x2, and spit out a number that is would determine these weights. So what I did was, firstly, I invented the weights system of different cards. If a decision is closer, the weights will be closer together. And what that is that each of the 2 cards in the robot's hand, because on your turn you have 2 cards, each of them has assigned a weight, say 1 and 2. And what the computer does is plugs them into a probabilistic or deterministic function and spits out which one you should play. In the deterministic function, the card with the bigger absolute weight, so between 1 and 2 it would be 2, between 2 and -3 it would be -3. It plays that card every time. In the non-deterministic one, it sums the absolutes of the weights. So for 2 and -3 it would add those, add 2 and 3 and make 5. And then it would divide one of the weights by the sum. So 2 divided by 5, 0.4. It would then generate a number between 0 and 1, such as 0.26817, whatever. It would be 10-ish digits long. And if that number is less than the weight divided by the sums, then it plays the first card, otherwise it plays the second, roughly speaking. And so what I needed to do was create a function that would convert the 2 input numbers, the 2 cards in hand, x1 and x2, where x1 and x2 are natural numbers between 1 and 8, and do some maths to them so that it can spit out some weights, y1 and y2. And so the way that I decided to resolve this was using sine functions. So sine functions are special. Let me just draw one, because they have they can be positive, they can be negative, and they have periodicity. And so my thinking was, if you can sum a bunch of sine numbers, a bunch of sines, then you could make a graph which goes up and down depending on these 2 axes fluidly. And so your 1, 1 could spit out 5, but your 1, 2 spit out minus a million or something. Like if you tinker with the periodicity and the coefficients of sine correctly, then you could produce potentially any graph for these natural inputs of x1 and x2. And so the function essentially became the sum of alpha I sine beta I x1 plus beta gamma I of x2 from I equals 1 to from I equals 1 to I equals n, whatever. And so, hopefully using that sort of graph, I could map the two-dimensional inputs into outputs, and I'd have one for y1 and one for y2. So I'd have alpha 2i sine beta 2i, well not 2i, but the point being I would fluidly map the inputs into weights. Now, a problem I came across was that the model was kind of simple and rustic, and that theoretically I could train it to be good, but it simply doesn't have the sort of iterative process that I would want. And so what I ended up doing, and also it's hard to put lots of inputs in and have them be order-based, because in the end I want my AI to be able to take in every card that's been played already and all the decisions the opponent's made. So what I ended up doing was using matrix multiplication. And I think my handbook, where from my original notes is still around here. Yeah, I've got it. And so what I ended up saying was, my input is the vector x, where I go from x1 to xn. So input x, which is equal to x1, x2, ... xn. And my matrices m alpha, where alpha is just some natural number, is an n by n matrix. So if the input x is 14 dimensional, which it ends up being in my program, then m1 is a 14 by 14 matrix, m2 is a 14 by 14 matrix, etc., etc. My system of scales is that I would generate a number y number, so for example y1, which is equal to m1x. So y equals m1x, so y1 equals m1x, and then I would process, so that gets me a matrix multiplication of this vector. What I would do is create z1 by doing matrix multiplication on the signs of the result of y1. So A alpha is also an n by n matrix. So I would do A1 on the signs of y1 to make z1, roughly speaking. All of this maths is kind of, I'm just sort of trying to say it. And then yn, to generalize it, is equal to mn y of n minus 1, and zn is equal to an sine yn. And then, to get my output, I would have m prime, which is a P by N dimensional matrix, where P is the desired output dimensions. So the output, which in this case is 2 dimensions, so M prime is a 2 by 14 dimensional matrix. The output is M prime times Y omega, so Y omega is the last Y, because you can theoretically do this infinitely as long as you have more M's and A's. And yeah, so you spit it in and you bring it out, and in order to visualize that, you can imagine it being like a network, where I put my input in. This is a 14-dimensional matrix, and for each of these nodes, the numbers go off and are multiplied by weights. So then you have these 3 numbers here, and for each of those numbers, those are multiplied by other weights and added to other things, and then you throw in signs and stuff, and then eventually it's all consolidated. Here's the thing. I didn't realize this at the time, but I probably should have. I just invented neural networks, but with a non-reversible function, the sine function, instead of a traditional sigmoid function, which is reversible. And when I realized that, I was like, well, shit. Because I haven't done anything new. And it means that there is a very easy calculus-based way for me to train what I realize now to be neural networks, using their success and their defeat and data. But it would require me to do calculus in vectors and stuff, and it's like, oh, who has the time? Not I, because I had 4 hours left at this point, or whatever. So I just sort of slapped together a way of generating these networks. It would randomly generate the matrices, it would randomly generate the A matrices and M1s, go through layers, spit out numbers, and then I implemented it into my main code so that these random networks could fight each other. And basically that worked. So my plan would be to generate an AI and have it fight another one. And then the winner, I would modify slightly. I would have it evolve. Well, I would make 100 AIs, or 10 million, or whatever, and have them all fight each other. Half of them get knocked out. Of the 50 million remaining, I would slightly evolve them. I would change the numbers slightly, tweak them up and down, whatever, blah, blah, blah. Have those all fight each other, and then just keep repeating this process until presumably a more refined type of AI comes out. And occasionally I play them to make sure they're not generating some kind of incestuous meta that my feedback loop considers appropriate. But the more practical way of doing it would be to generate a bunch of data, to play a bunch of AI, love letter on my own, basically, against a very, very basic AI, and feed that data into my neural network so that it can try and learn, and then have that fight other players who are humans, and then have that data feed back into a main server. But unfortunately, I don't care enough about it anymore, and while a love letter AI would be fantastic, no one's even heard of the game, so, like, who gives a shit?